Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel. Today's topic of discussion is one MCQ. The question is in front of you. Which reagent is most appreciable for this conversion? Four options are provided. This question is little tough, student. I request you please pause the video, try by yourself, and whatever answer you get, please write in the comment box. Don't hesitate whether your answer will be right or wrong, because after some time you will get right answer with explanation. I believe you have tried, so let's start. Now, question is which of the reagent is most appropriate for this conversion? Means this double bond is actually epoxidized. This, how you can do. By the way, generally we do this reaction using MCPBA. And this is electrophilic epoxidation. So electrophilic reaction. But here is no MCPBA given. That's the toughness of this question. This is relatively difficult. So let's go step by step. So here I have taken reagent bromine in carbon tetrachloride, then KNH2. Why? If you take bromine in carbon tetrachloride, first it will produce this dibromo derivative, and later on upon treatment of excess potassium amide, it will produce this 1-butyne terminal alkyne. For actually here potassium salt will be produced, upon workup this alkyne will be produced. Second, option B, sodium hydroxide and hydrogen peroxide. Will it be able to oxidize? Because hydrogen peroxide is an oxidizing agent. Student, there will be no reaction at all. Actually, MCPBA can oxidize because this is electron rich. This MCPBA is an electron deficient peroxide, so it can oxidize, but hydrogen peroxide is not, because in presence of sodium hydroxide, hydrogen peroxide will be converted into hydroperoxide anion. So this is electron rich. That's why it cannot epoxidize or oxidize this carbonyl, because there will be a repulsion between the electron density on this oxygen and this pi bond. So no reaction. Third, C, ozone and carbon tetrachloride. First it will be a ozonolysis. So actually in this way breaking will happen. So one side will be formaldehyde, another side will be propionaldehyde, and obviously whatever the hydrogen peroxide is produced, that will be quenched by the zinc dust water. Okay, so 2 aldehyde. So that's not the product. Now obviously you can say sir option 4, because only this is remaining. Okay, so let's start. NBS, THF, then what happened? First, if you react it with NBS, NBS means N-Bromosuccinimide. So here nitrogen is attached to Br, and nitrogen is more electronegative than bromine. So this is delta negative, bromine is delta positive. So bromine is electrophilic reagent. So that's why it can react with pi bond. It acts as a nucleophile. So pi bond will attack and it will produce ultimately bromine attached here, carbocation here. See, NBH in THF water. So water acts as a nucleophile. So what it produces? So it produces, this is Br, this is actually, I can write this Br in a different way. This is Br, this is water. It doesn't matter because CC rotation is allowed here. So in the next step, sodium hydroxide. So this is actually bromohydrin. Remember the name of such molecule. Since bromo is there, this is bromohydrin. So base abstract this proton, produces O minus, and student these O minus attacks here, it leaves. So obviously what is the product? Epoxide. So option D is the right answer. These questions are student pretty confusing. It is very difficult. If you have very good grip on organic chemistry and you can calculate this thing in your mind step by step, you can get the right answer. Otherwise, I suggest you write whatever the product. And these are very time consuming questions. So prepare your knowledge and practice such a way that you can reduce the time. The challenge of such question is reduce the time to solve this question. Because if it kills your time, it will give you less time for other questions. So that is the problem. So practice and obviously follow the lectures. I guess it will help you. So thanks for watching. See you in my next video. Bye-bye.